Hey, so I've upcoded an operating system. It runs on x86-64. It does cooperative multithreading. There's no memory protection. It's written in Rust, no dependencies, including the bootloader, written in assembler. And it was mainly written with Claude code. We'll get to that later. Maybe a demo first. Let's start it here. And the first thing we see is that it comes up with this interesting thing here, which is actually a memory map. We'll get to that in a second. The other thing is that we get a serial console where we have Ralph Basic. By the way, the name Ralph comes from Jeffrey Huntley's awesome article, Ralph Wiggum as a Software Engineer. I did not go full Ralph on this, so I still steered the model and iterated, but still it was somewhat of an inspiration. Another inspiration, by the way, was Temple OS, which is where I got this. Let's just do simple stuff, no memory protection. If you don't know Temple OS, you should totally look it up. It's crazy. There's also a sad story behind it. But let's go back to our operating system. So let's load a file. By the way, there is no file system here. There's just a couple of files that are baked into the image, all of which, of course, fits into a 1.44 megabyte floppy disk. And this is one of them. If we list this just prints a bunch of Fibonacci numbers. Okay, easy peasy. By the way, you might have seen that stuff happened here in the memory map. If we go here, we can see that there's like a little bit of memory occupied by the basic REPL. This here is the code of the kernel. This here is free part of the heap. These are stacks here. And you can see there's like some stuff here that we haven't talked about yet. By the way that this is laid out is via a Gilbert curve, which is a variant of the Hilbert curve. It's a generalization to a rectangle. And one of the nice properties of the Hilbert and also the Gilbert curve is that neighboring regions will always have neighboring pixels. So usually if you laid out the memory map where it goes left to right, top to bottom, once you go to the end of a line, it restarts with the next line. And so you have this discontinuity, which does not happen with the Gilbert curve. So let's do something more interesting. We have a multitasking operating system. Why don't we run multiple things? Let us telnet into the system, and it does not work, of course, because I have to say localhost. And you can see, again, we're in Ralph Basic, but it is a separate instance of Ralph Basic, and I can load a different program. For example, I could load a to-do. Now this here is about 180 lines of basic code, and you might see some interesting things here. You see some HTML. You also see some lots of string manipulation. There's a routing table, and there's some socket stuff. So let's go to localhost 8080. And that does not work because I'm not running it. Let's run it. Here's a to-do list. So this is a to-do list. We're going to build an OS, and then we're going to debug it, and then we're going to write about it. We're going to make a loom, and then maybe we built it, so let's cross that off. So this is an HTTP server written in BASIC. The TCP stack is actually implemented as a separate task. So if we come here again and we do memstats, you'll see that it tells you what the memory map is. And one of the processes here is network. And network is the process that actually implements the TCP stack. And then we have a bunch of basic commands that can open sockets and read and write TCP. So that's pretty much it. The amazing thing about this was that I really did not have to even look at the code. It was Opus 4.5 that wrote most of it. There were two hiccups. Well, there were three hiccups with Opus. So the first one was that with the VGA initialization, it just could not get it to work. And I had to do like some manual back and forth a couple of times until we got that right. Then a very similar thing happened with the mouse. But then the thing where it finally just would not fix the problem was that there was a TCP bug where you could make a bunch of connections, but then at some point it wouldn't accept any more connections. And so the web app really didn't properly work. And it kept excusing that on QEMU, even though I demonstrated to it multiple times that it's not actually QEMU. But it just kept using that excuse. It would not fix it. And then I switched to Codex with GPT 5.2, and in a single prompt, it found the issue and it fixed it. I was just gobsmacked. So kudos to Codex 5.2. That is awesome. I will definitely work more with that. I was already so impressed with Opus 4.5, but yeah, I guess I need to do Codex more. And that's it. Thank you.